This class we're going to learn a new function called reciprocals. And first, what is a reciprocal? Let's say 3 times 1/3 is 1. So I could say 1/3 is a reciprocal of 3. And then roughly speaking, what do you think of the definition of a reciprocal function? And let's just review. For a linear function, what's the simplest idea? In simple terms, we say that in a linear function, y and x increase or decrease proportionally. The constant of proportionality is its slope, k. And for a quadratic function, we say that the rate at which y increases relative to x followed a squared relationship. And of course, for a cubic function, y increases in the relationship of a cubic function. But overall, x and y still tend to increase together. As x increases, y generally increases too. But now, for reciprocal function, the definition becomes clear. When x increases and y decreases. For example, in some situations, if you work overtime, the more you work, the less you learn, because your marginal productivity drops. Or if you study more than 12 hours a day, let's say even 18 hours a day, the more you study, the lower your efficiency becomes. That declining trend in the later part of the curve, the decreasing curve, we call that as a reciprocal function. Let's say every day when you're studying below 5 hours, it's still increasing linear in a linear relationship, but after that, let's say after 10 hours, it will drop in a reciprocal way. It doesn't really matter how you define x and y. From just the very beginning, the opposite pattern, the more x you have and the less y you get. For instance, let x be the amount of the strong ultraviolet light you're supposed to, and then y be the survival rate of your cells. You will find the more ultraviolet light and the fewer your surviving cells are. So broadly speaking, a reciprocal function means as x increases and y decreases. It doesn't strictly have to be the form y equal 1 over x. It could be 1 equal 1 over x squared or 1 equal x to the power of 3. Any function that satisfies us x increases and y decreases can be loosely called a reciprocal function. Though in many school systems the term reciprocal function is strictly determined by y equal 1 over x, but mathematically we could be more flexible. And let's just study the simplest one, y equal 1 over x. How do we sketch its graph? Let's just start from its first quadrant, still by plotting points one by one. So the method is quite straightforward. Remember how we sketch the parabola or quadratic? We plotted points. So here, x is 1, 2, 3, 4, and we could get the value of y, which independently 1, 1/2, 1/3, and 1/4. And then we could mark those points on the system. So it's 1, 1, and 2, 1/2, and 3, 1/3, and 4, 1/4. Now, if we try to connect the first 2 points with a line, you can see the rest of the other points are not on the line. And if we connect the second and third points together, the other points are not on it as well. So you can see, obviously, it's not a straight line. And then how do we draw it with more precision? Well, we can just plot as many points as we can. Well, of course, you could also use a computer to help. But with more points drawn by the computer, you will see a curve has shown up. So it basically looks like this, a curved shape. And that's the true shape of the reciprocal function. And let me draw it more neatly. It just looks like this. And for negative x, still for this function y equal 1 over x. And 1x is -1, -2, -3, -4. We could get the value of y. -1, -1/2, -1/3, and -1/4. And we could also mark those points as well and still use the same way. We utilize the computer to draw more points, and after sketching them, connecting them, we will find it's a symmetrical curve with the first quadrant. And for beginners, this level is enough. We will go deeper into the graph's behavior, but now we can just focus on the first quadrant. When x is super small, let's say when x is 1 over 100, or 1 over 1000, or 1 over 10,000, or 1 over a million. So what the value would be? So you see, y is the reciprocal of x. So if x is 1 over 1 million, and x is 1 and y is 1 million. So when we draw it on the graph, you see when x is super small and y is super big, but it's still in the first quadrant. And the same rationale can be applied to when x is 1 billion, 1 over 1 billion, and so y would be 1 billion. So if we draw it higher, it will still be the first quadrant. So we can see when x is super small, when x approaches 0 from the right, y goes to infinity. It's just super large, but it's still in the first quadrant. And we could get the conclusion that y equals 0 is its first asymptote. Asymptote means that you're getting closer and closer to the line, but never interact with it. It's always approaching. And once you understand the vertical asymptote, we could still make the value of x close to infinity. Let's say when x is 1 million. If x is 1 million, so y would be 1 over 1 million. So y-axis is super big and y is super small, but it's still above the x-axis. And when x is 1 billion and y is 1 over 1 billion, it's super small but still above the x-axis. So when x is infinity, y is almost 0, but still greater than 0. It's still above the x-axis. And we could get a conclusion that the curve is always approaching x-axis, but never interact with it. So we can call y equals 0, this horizontal line is its horizontal asymptote. I'm sorry, the first asymptote is x equals 0. So you see, y equal 1 over x, it has two asymptotes. The vertical one is x equals 0, and the horizontal one is y equals 0. I could show you a very useful property of this function. Take any point on y equal 1 over x. Let's say I take 2, 1/2 on this point. It's point A. So figure out the area covered by this region. So its x coordinate is 2 and y coordinate is 1/2. So the area would be 1. And let me take another point. So it's 1/2 and its y-axis would be 2. It's called B. The area covered by this region is also 2 as well. And let me find another point. 3, 1/3. So the area enclosed by this region is also 3, because it's 3 times 1/3 is also 1. So given you any point, its x coordinate is A and its y coordinate is 1 over A, its area would still be 1, because its x coordinate will be A and y coordinate is 1 over A. So its area will always be A. And that is a really useful property in this reciprocal function, because when you remove x and y in the same side, you will find x times 1 is always 1, which is exactly the area covered by the region that I have drawn. So what's the general form of a reciprocal function? Let me just give a simple one. Y equal x k over x. K could be any value. Let me just take y equals 2 over x or y equals minus 3 over x. And their graphs looks quite similar, just steeper or shallower. For example, y equals minus x over 1. So its original shape would be what I have shown before. And if you put a minus sign here, it could just be symmetrical, like the yellow ones. You can just do reflections very easily to draw its graph. And one x is 2, one here is 2 here. You can just imagine you're stretching the graph on the y-axis with a scalar 2. But we don't really test how precise they're looking like. You can just roughly draw it as this way. Its horizontal and vertical asymptote wouldn't change. The numerator 2 just means to double its y-axis on each point, but the whole picture is still looking like its original shape. And for y equal 1 over x squared is also a kind of reciprocal function, and if you're trying to sketch it, still plot more points on the graph. 1x is 1, 2, 3, 4, 5. The value of y would be 1, 1/4, and 1 over 9, 1 over 16, 1 over 25. And when you plot those points on the coordinate system, it's just 1, 1, 2, 1/4, 3, 1 9, and 4 over 1 over 16. It still basically looks like this. Just compared with y equals 1 over x, it might be steeper, but it's not really important. You can just basically roughly remember that the shape is like this. It's just a curved shape. And in summary, the standard reciprocal function, y equal k over x, you can just remember the basic shape of 1 over x over 1 and then do a bit of dilation or reflection to draw the other shapes. And that's a really useful method.